Alright guys, so welcome to week 3 screencast, and what I'd like to do today is do a kind of a review on the Java memory model. We're going to look at the Java memory model more formally in week 5, but what I'd like to do today is connect some of the material that we have learned about how memory gets allocated on the stack, how memory gets allocated on the heap, by looking at a really simple Java program. Okay, so what I have here is a car class. I have a class called car. And what is a car? A car is something that has an engine. A car is something that has a gasoline capacity. It has a capacity to contain fuel. It has a car color. Okay, so let's keep it simple for the time being. Let's just assume that this is what a car is, and of course it also has wheels. So I'm assuming that my car has four wheels here. And what I've just mentioned here, these entities make up my instance members. So four wheels, the car color, the gasoline capacity, and the car engine are nothing but my instance variables. These are my instance members. Okay, and how do I create a car? Well, I have my constructor is overloaded. So I'm using the idea of constructor overloading to have 3 different ways of creating a car object. The very first constructor is basically the default constructor, and this is something that's applied, that's given to you directly when you do not provide any constructors in your car class. So if I have a class which has no constructors, the JDK will implicitly provide me with a default constructor. But if you, as a developer, were to provide any single constructor in your class, then the default constructor, which is just selected, is not given to you. Okay, but the reason I've just written it over there is just to give you the idea that when I talk about a default constructor, it's a constructor that takes in no parameters and basically doesn't do anything within its implementation. It just returns back a empty car object. Okay, what's my second constructor here? The second constructor also creates a car object, but as an input parameter, it takes in a reference of type engine. And my third constructor over here is a constructor that takes in 5 local variables. The first parameter is an engine, and the next 4 parameters are my wheels here. Okay, and so there are 3 different ways of creating a car here, and let's just go ahead and write some code that basically put this in practice. Okay, so what I'm going to do first thing, I'm just going to get rid of the things over here. So let's just start from a blank screen, and let's just create an engine here. So I'm just going to create a generic car engine. Okay, equals to new engine. Okay, so I've created an engine there. And let's create my 2 cars here. My 2 cars are Ferrari equals to, and you might have guessed that the way I'm creating my Ferrari is I'm invoking my second constructor, which is this one over here. I'm invoking this constructor. What does this constructor do? Well, it takes in as an input parameter something of type an engine. Okay, so let's go back to our test.java. Am I passing something of type engine? Well, I'm doing that. I'm passing in a reference generic car engine, which is of type engine. Okay, good. And let's just create one more car object. Let's just create a BMW. And I'm just going to invoke the same constructor. There you go. Okay, so let's draw the Java memory model for the code that I've just written here. Okay, so first thing first, let's look at the first line here. What's happening? Well, and on this line, I'm creating a reference called generic car engine. The reference generic car engine is a local reference, it's a local variable. All local variables get allocated on the stack. So the memory for this local variable gets allocated on the stack, the code that I've just selected. Likewise, on this instruction, I'm also creating something on the heap. What is that something on the heap? That something on the heap happens to be an engine object. How do I know that? Because I'm using the keyword new followed by the constructor, and this is an indicator that this object over here, the engine object, is allocated on the heap. Okay, so I'm creating a reference generic car engine, and that gets allocated on the stack, and I'm creating an engine object on the heap. Now how are these two things connected here? So think about the generic car engine as containing a value. That value happens to be the memory address of where on the heap this engine object happens to be. Okay, so the generic car engine is a reference created on the stack. As a value, it contains the memory address of where this engine object is on the heap. Okay, so as a value, it contains the memory address of where the engine object is on the heap. Okay, so let's just get rid of this comment here, and this is what's happening so far with that instruction. And likewise, what's happening over here? So with my Ferrari car, what I'm doing is I'm creating a reference Ferrari that gets allocated on the stack. Okay, this Ferrari over here gets allocated on the stack because it's a local variable. This piece over here is a local variable. Okay, so Ferrari is a local variable that gets allocated on the stack, and as a value, it contains the memory address of where the car object, this is a car object that I'm just creating on the heap. Okay, and likewise, the same idea repeats over here. I'm creating a reference called PMW that gets allocated on the stack, and as a value, it contains the memory address of where the car object is on the heap. Okay, so how many different objects am I creating so far? I'm creating 3 different objects. That's my first object right there. This is my second object, and this is my third object. Okay, so let's just draw this on a memory diagram. So what I'm going to do is I'm going to use my Google Docs. So let's do a separator here. This is my stack. This is my heap. Okay, and I haven't yet introduced the idea of a stack frame yet, and I plan to do that in my week 5 when I introduce this topic more formally. But what we've learned so far in the class, I'm just going to stick to that, to those concepts. I do not like to get ahead of myself here. So so let's see what gets allocated on the stack here. So on my stack, what I'm seeing here is I'm seeing that I'm first, if I look at this entire instruction here, I'm first creating a generic car engine. Okay, so let's just create this on a stack here. So I'm going to say on my stack, what I have here is a generic car engine. That's my local variable. Okay, what does it contain as a value? As a value, it contains the memory address of where I'm creating this engine object on the heap. So on the heap, I'm creating an engine object. So let's draw this engine object on the heap, and think of this nothing but as a pointer that's pointing on the heap and this engine object. And let's just give it a name here. This is my engine object. Okay, let's look at the second instruction. Okay, on my second instruction, what I have here is car Ferrari equals to new car generic engine. So what I'm doing first thing is, let's just break this problem up. I'm first creating a local reference. I'm creating a local reference called Ferrari on my stack. So if I go back on my stack here, I can say I created a local reference called Ferrari.